In this tutorial, I'll be further explaining the results shown in the PL post. So I'll start off with a simple square slab and the four columns that I already solved before in the previous tutorials. So I'll simply go to the folder, open the tutorial1.lc. I'll click it, and it should open up in the PL post. First thing I'm going to start off with is I'm going to draw a strip across the slab. So I'm going to go and select draw strip, click and drag across the slab. And then I'm going to go and click on solve to solve the strip. It should solve successfully as shown here. I'm going to click OK. And then I'm going to scroll up and down, and there we go, we have results. Now to adjust what you view in this curve, we will open the Results Manager. The Results Manager can be opened through either the button at the top over here, or I can simply right click anywhere in the space and choose Results Manager. Now as you notice that the strips have been updated, and you can change the ID as mentioned before in tutorial 3 to any other name of your choice. I can change the number of points, the type of result that I want to view, or I can enable it or disable it. Obviously this feature is very useful if you have several strips. I can also modify the start and the end points of the strip. So I'll make the start say 3, 2. And I'll change the end to say 0, 2. And I'm going to click OK or close. I'll scroll up and down. Obviously there are no results because I've changed the type of strip that I have. So I need to resolve it. So I'm going to click on solve and it solves it. Let's scroll up and down, and there we go. I have my new results. This feature is obviously more useful for more advanced users. As mentioned earlier, I can also change the number of points. The number of points, as mentioned in previous tutorials, increase the number of points along the strip, thus providing a more accurate presentation of the curve. So I'm going to right click Results Manager and say I'm going to change this number of points to 50. I'm going to close it, scroll up and down. There is nothing because I need to resolve it because the number of points has changed. So I'm going to solve it, and it's going to tell me that it solved 50 out of 50. I'm going to click OK, scroll up and down, and there we go. I have a more accurate curve. I can also adjust the scale through the slider. This is a very useful feature in the Results Manager over here. Now, it's useful because when dealing with several strips on different surfaces, thus one needs to be uniform in scale to be able to compare, whilst choosing a suitable scale to be able to view the several strips near to each other. At the same time, this allows the person or the user to quickly analyze and compare between the different strips of the different surfaces. So for example, I'm going to make my strip a little bit smaller here. I'm going to close it, scroll up and down to refresh. As you notice that the peaks of the curve have become smaller. The Solve That to be solved option here in the drop-down menu is a way of telling the program to solve the strip again. This is very useful if we change the number of Gauss points in the controls dialog box in the PLGen. The To Be Solved option is also useful when I have several strips along the same coordinates. So basically what I'm trying to say here is that if I have several strips that I need to be solved in the same coordinates but on different results, I can just put them all to be solved, to be solved, to be solved. And then later on when I need to solve them, I can simply choose solved. Now I'm going to go on to the contours. Now, as mentioned before in tutorial 3, there are 3 types of contours: the main contour, rectangular contour, and the quadrilateral contour. The main contour can be simply enabled with the Results Manager. So I'm going to enable it here. I'm going to click close and scroll up and down, but there's nothing because I need to solve it first. So I'm going to click on solve. It's going to solve the internal points. I'm going to click OK, scroll up and down to refresh, and there we go. I have the contour map. Now you can enable the legend on or off through this button over here to basically define what the colors represent. The minimum and the maximum are very useful tools. For example, say I'm looking for a specific range of MXX for the design of the reinforcement of the slab. Thus, I can specify a certain range, say between 1 and 2. Now, automatically, the maximum and the minimum user-defined radio buttons are ticked automatically. So I'm going to close, scroll up and down, and there we go. Now the contour map appears only in the areas within the range I specified. However, the range is too large, meaning the number of colors is too much. Thus, I'll go back to Results Manager, right-click Results Manager. I'm going to change the number to say 4 instead of the default 8. I'm going to click Close, scroll up and down to refresh. Now, we notice that the legend and the contour map only has 4 colors. Another important tool or useful tool in the results manager is the spacing, which is basically the distance between the points that will be solved in the model. Thus, if you decrease the space, you will increase the accuracy, but it will take longer to solve the model. For example, I'll take the spacing here at 0.1 instead of the default 0.5. I'm going to click close. Scroll up and down to refresh, and there's nothing because I need to solve the model. So I'm going to click on solve, and it's obviously going to take time to solve it because the number of points has increased a lot. So I'm just going to wait here until it solves it, and there we go. Now as you know, there's a dramatic increase in the number of points. I'm going to click OK, scroll up and down, and it loads the contour map. Notice that after running the model, the contours have become finer. In the sense, their edges are not chunky anymore, and more areas have appeared on the top that were not previously seen because of the spacing between the points was much more than this. There are other types of contours as mentioned before in the tutorial, the rectangular and the quadrilateral contour. Their settings can also be adjusted in the same way as the main contour. The type of results that can be shown in both the strips and the contours are the same. In this case here the results, and here in the contours the current variable. When saving this file, it's very easy. Basically, you just click on save here or file save, and the extension on which it saves is .res file, meaning that it saves it as a results file. The file is saved with the load cases and the load combinations. In the results file, the column plot will also be saved along with its data. So I'm just going to click here, save, tutorial1.ris, say replace it, and there we go. And this concludes our tutorial.